Session chairperson, stupendous speakers on the dais, distinguished delegates, ladies and gentlemen, and to all the proud papermakers, a very warm good evening to one and all. I am Gokulakannan from Tamil Nadu Newsprint and Papers Limited. I feel delighted to be here today, and I am going to speak to you about our efforts done in the shop floor level and the results we obtained in terms of energy conservation and optimization. So our topic is as simple as that: energy saving efforts and results in TNPL. When fostering the future of energy and environment in pulp and paper industry, we are in the urge to make all the possible moves to overcome energy crisis and environmental issues like shortage of resources, sudden upticks in demand, less falling water levels, less significant rainfalls, global warming, climate change, greenhouse gas emissions, and so on. And so it is so definite we need more innovation and best practices to be implemented. TNPL is a leading agro and wood-based paper and paperboards manufacturer across the globe. We are currently operating at 4 lakh metric ton per annum of paper and 2 lakh metric ton per annum of paperboards, accounting to 6 lakh metric ton per annum. And our vision is to make 1 million metric ton per annum by the year 2030. TNPL, driven with the concepts of manufacturing excellence and energy management system, has provided us guidance and support to conduct several case studies in terms of energy conservation and optimization, which were experimented and implemented and proved to be energy efficient and reduce the overall energy consumption. We are able to achieve the results by sincerely adhering to the energy management system. The main functionality to consider in energy management system is to have connectivity with the devices, continuous monitoring and tracking, instant notifications, and data analytics and reports. When you have all these in hand, you will be able to easily identify high energy consuming assets, and you will be able to derive a solution to optimize it, and thereby you will be saving a lot of cost measures, and you could set a benchmark for making process with more energy efficient, and you could bring out a world-class standard in energy efficient production. TNPL has a well-established energy management system across mill-wide. Let me elaborate on the system that we have in the paper machine. Our energy management system architecture has a data server equipped with SCADA software and data concentrators and energy meters. We have installed energy meters for high energy consuming equipments in all the 3 machines. Numbers are 29 meters in PM1, 24 meters in PM2, and 40 meters in PM3. So it gets the live data and it transfers to the data concentrator installed in each machine. This communication is happening via RS458 series communication protocol, and the communication between data concentrator and to the server is via our existing ERP network. So with the features of energy monitoring system, real-time data are collected, compared, compiled, and analyzed, and we could able to generate reports for the energy consumption machine for all the 3 machines, and we have graphs and trends to compare all the 3 machine energy consumption. And from the reports, it was evident that the major energy consumables could be classified into categories as sectional drives, vacuum pumps, refineries, and pumps and auxiliaries. So from the report, we decided to concentrate on pumps and auxiliaries section since it is also one of the major contributor for high energy consumption, around 3.22 megawatt in PM3. And 3.56 megawatt in PM2 and 2.85 megawatt for PM1. So we decided to concentrate on pumps and auxiliaries to identify is there any scope for energy saving in the high energy consuming equipments. Let me highlight a quote here: little drops of water make a mighty ocean. Our paper elaborates further on how making minor modifications in the process or the system could reap us a huge amount of savings in terms of energy and energy cost. So our first case study is energy saving by modifying the logic in pulper operations. So this is the picture representation that is taken from the DCS real pulper picture. We have 6 numbers of pulpers installed and working in PM3 from wire pot to winder. Out of that, we take 2 pulpers, real pulper and pre-dryer section pulper in manual mode often. The main purpose of pulper is to slush the loose broke that it receives and it discharges to the next process. Out of the 6 pulpers, as I said, we take 2 pulpers often in manual mode to handle the loose broke that is getting generated from machine brakes, winder brakes, reel spool handling, or end core handling, whatever. It handles the loose broke that it receives. So as per the existing logic, we observed that whenever the pulper is taken in manual mode, the agitator would run for 600 seconds continuously before it goes off. So the pulper is equipped with 315 kilowatt agitator motor capacity. So every time it gets on, this agitator would run for 600 seconds continuously before it goes off. So we discussed with instrument team and we studied, and after finding the fact 600 seconds of agitation would not be required for slushing the loose broke, we decided to reduce the time in the logic. So we approached the instrument team and we reduced the agitation time in the logic from 600 seconds to 400 seconds for these two pulpers. So the average running time of these pulpers, the average running time of real pulper was 12 hours per day, and for pre-dryer section pulper it was 7 hours per day. By reducing 200 seconds of agitation time in logic, the average running time has came down to 9 hours per day for real pulper and 4 hours per day for pre-dryer section pulper, saving us 3 hours per day of agitator running. That is 3 hours of 315 kilowatt motor running saved per day. When you look at the cost saved from this minor modification, as I said, this motor capacity is 315 kilowatt and running power is 240 kilowatt. So you saved 3 hours of running power. So 3 into 240, 720 units saved per day. Considering 6 rupees per unit, we are saving 4,320 rupees per day for each pulper. So that is, when you calculate it per annum, considering 330 days of operation, excluding shutdown and breakdown, for 330 days, you are saving 14.25 lakhs per annum for real pulper and 14.25 lakhs per annum for pre-dryer section pulper. That gives us 28.5 lakhs of cost savings by modifying agitation time in logic by 200 seconds. So with efforts to save minimum power, we incurred cost saving benefits of 28.5 lakhs per annum from this first case study. Our next case study is reducing power consumption by stopping 6-bar pump and white water makeup pump. In paper machine, we have different pressure pumps for the process requirement, like 3-bar, 6-bar, 30-bar and 70-bar for the high pressure servers in wet end. So the main purpose of 6-bar is to supply desired water pressure for retention chemical preparation system and for cleaning of stock and wet end area during necessary time. So other than the retention chemical preparation system, the need of cleaning will be required only when there is machine stoppage or break. So there is a scope for energy saving if we could find an alternative source to service the need of retention chemical preparation system. So what we did is, so this is the existing schematic picture. The bottom pump is the 6-bar pump that is going to the retention chemical preparation system. We introduced a new interconnection line between freshwater supply from WT water treatment plant to the 6-bar line delivery, and with the manual valve. This interconnection line is new line which we modified and with a isolated manual valve. So after making through this line, we closed the 6-bar delivery, and this incoming pressure from water treatment plant could able to suffice the need of retention chemical preparation system, because the incoming pressure was around 5 to 6 bar. So it is more than enough for the retention chemical preparation system. And we provided a recirculation valve in the 6-bar delivery, and we kept it at percentage that it could maintain the warm water tank level to the safe working of the paper machine. So energy cost benefits from these two pumps, swapping these two pumps. The 6-bar pump is 55 kilowatt motor and the white water makeup pump is 30 kilowatt motor. Both are running at 25 amps and 15 amps. So saving 600 plus 360, 960 units per day. So that gives us around 11.88 lakhs per annum in 6-bar pump and 7.13 lakhs per annum in white water makeup pump. So that gives us around 19 lakhs per annum savings by stopping these two pumps without affecting the existing paper making process. And our next case study, reducing power consumption by providing VFD in hydromix makeup pump. So this is again the pictorial representation of the DCS diagram. We are talking about this DOD pump. This DOD pump, the purpose of this pump is to pump the excess water from DOD to hydromix, to silo, to maintain the level as per the process requirement. This pump is equipped with DOIL. This is DOIL pump, direct online starter, and it runs continuously at full speed, 100% speed. And this level to the hydromix will be controlled by the control valve, which will be operating at 30 to 45% opening only, always. So there is obstruction in the valve, which is restricting the flow, whereas pump is running at full speed at all times, 100%. So what we proposed is to introduce a variable frequency drive instead of this DOL. We could able to control the flow by varying the speed so that the running power will be reduced and there will be power saving by doing this modification. So we installed a VFD for this DOL pump, and this running power got reduced drastically from 76 amps to 21 amps just by installing VFD in this mega pump. And the control valve, which were operating at 30 to 45% opening, increased up to 80 to 85% to maintain the required hydrodynamics level. There was no disturbance in the process. Everything was working seamlessly fine, and we reduced the power consumption from 76 amps to 21 amps. That gives us around 14 lakhs per annum savings. So for VFD installation, we invested around 3.5 lakhs. That could be got back in 4 months by this savings due to VFD. And our final case study is reducing water and power consumption by replacing fresh water in the size press filter flushing. So I'll go a little bit faster. We have size press applicators equipped with 5 filters, and these filters will be auto flushed every 40 to 50 minutes once as per the starch quality and as per the required DP. And we are using 3 bar water, fresh water, for this filter flushing. It is observed that whenever there is flushing occurs, there will be pressure deviation in the 3 bar delivery. And to avoid the deviation, we will be always keeping the set point higher, up to 400, 450 kPa we will maintain in delivery to avoid the fluctuation. What we did is we introduced a new line from machine backwater to this filter flushing header, and we closed the 3 bar delivery, which is going to the filter flushing. We used backwater for filter flushing, and we stopped the pressure deviation in the 3 bar delivery. We reduced the pressure set point, which were maintaining at 400. We reduced it to 250 kPa to 2.5 bar. After this modification, so this trend shows that before modification, there was heavy fluctuation in the pressure as well as power. Whenever there is pressure fluctuation, the pump speed varies and the power varies. After modification, it has come down, both the pressure fluctuation and the power fluctuation, and we have saved also the water. Because we changed backwater in place of fresh water, we saved 70 m³ per day. Again, looking into the cost benefits by this project is around 8.5 lakhs per annum. Power saved because we stopped the pressure fluctuation in the 3 bar delivery. We reduced the delivery set point from 4.5 bar to 2.5 bar, and we saved water up to 70 m³. So by doing all these small modifications, around all these 4 projects could account up to 70 lakhs per annum cost savings from all these minor modifications in the system. So in a nutshell, the pulp and paper industry is facing significant challenges in the growing demand for environmental friendly products. These challenges are multifaceted, and it requires a comprehensive approach to address them. So one of the key solutions is to adapt sustainable practices. Energy cost saving measures are of much importance for the companies to prioritize. By reducing energy costs, companies can increase their profitability and while also being sustainable. Hence, implementing measures like efficient energy production and reducing water usage could lead us to sustainable and eco-friendly environment. The famous Hollywood actor Denzel Washington always used to quote in his speech, "Without commitment, you will never start, and without consistency, you will never finish." On top of that, I would like to add, consistency is the key to success, and continual improvement is the key to sustainable profitability. So when fostering the future of energy and environment, let us all put an impeccable attention in detail to the existing process and the system, and let's all focus in the continual improvement of the process to make the best out of it. Thank you. Thank you. Thank you for having me. Thank you, IPTA, and I thank my organization, TNPL, for allowing us to conduct these small case studies, which reaped us huge benefits in terms of energy and energy cost, and I thank you all.